Okay, class, so today we're going to talk about basic differentiation techniques. So you'll learn some of the basic ways to take a derivative as well as going over how to write the equation for a tangent line and also the equation for the normal. So let's begin. Here are the first four rules that we're going to go over, and you'll be using these constantly and in combination. So our first one is the constant rule. So anytime you have a constant, right? So when you don't have a variable and you do just have a number, the derivative of any constant will always be 0. If it is negative 400, 3, 6, 8, 10, the derivative of every constant is always 0. This rule right here you'll be using a lot, and it's the power rule. So what the power rule states is you're going to take the power and put it in front as a coefficient. And then what you're going to do is subtract 1 from that original power. Okay? The constant multiple rule is saying if I'm multiplying a term by a constant, then all I'm really going to do is keep that constant and multiply it by the derivative. And the sum and difference rules just say that if I have a polynomial and there are multiple terms to it, I can just take the derivative of one term, add or subtract the derivative of the next term, and so forth. So let's do a couple examples so you can see how these rules are used. So it says find the derivative of the function. So if you take a look, I have 5 terms here. 1, 2, 3, 4, and 5. And so if I look at these, 4 of them have powers, right? So the 4 underlined in blue have powers, and this one underlined in red is a constant. So according to our 2 rules, I have to use the constant rule as well as the power rule. And technically, I'm also using the sum and difference rules. So if we do this, the power rule says take the power and make it the coefficient. So for the first one, I'm going to take this 4 right here and make it my coefficient, put the x, and then I have to subtract 1 from my power. So 4 minus 1 is equal to 3. And I continue, since this is a plus sign right here, I'm going to write plus, do the power rule again, drop my 3, put an x. If I subtract 1 from 3, I get a 2, which gives me a squared. And again, plus 2x. Well, if I have a 2 right here, subtract 1 gives me a 1. Plus x, well, the power of x is 1, and I'm going to get x to the 0 power, right? And the final term is a constant, and we said the derivative of any constant is 0. So I'm going to simplify these terms right here, and I'm going to get 4x cubed plus 6x plus 2 plus 1, because any variable or any number to the power of 0 is always equal to 1. And this right here is my derivative, f prime of x. X is equal to 4x cubed plus 6x plus, 2x, sorry, 2x plus 1. Good. So let's do another problem. So in this problem, you're going to see we're not only going to use the constant rule, the power rule, the sum and difference rule, but we're also going to use the constant multiple rule, since all our terms have a coefficient already established. Right, so those are my 3 coefficients. So if I continue this, I'm going to multiply my powers. So I'm supposed to have a 2, but the derivative of this piece right here is 3x squared, right? So I'm going to continue. The derivative of x squared is 2x plus 3 times x to the 1 minus 1. And we said the derivative of any constant is always equal, is equal to 0, so it's going to be, let me erase that real quickly. It's going to be a minus 1. I'm sorry, minus 0. If I simplify this, I get dy dx, which is a notation for the derivative of y, is equal to 6x squared minus 8x plus 3. Once again, this cancels out. So as you can see, you can actually do a lot of these steps without showing work. You can combine all of them at once. For example, this piece right here, you never really have to write that down. I'm just showing that to prove to you that this will cancel out since any number or variable to the 0 power is equal to 1. Alright, so let's take a look at this problem here. How is this different from our previous problem? Well, yes, they're fractions, but if you notice, I have a square root term. So anytime I have a term like this, I'm going to want to rewrite it so I can have a power instead. So if I rewrite this, I get f of x is equal to x to the 1/2 plus x to the 2/3 plus x to the negative 3 over 4. Okay? So let's go ahead and take the derivative. I'm going to get f prime of x is equal to, I'm going to move my fraction in front since that's my power, x, and 1/2 minus 1 is negative 1/2. Once again, move my power to the front, 2 over 3, x, 2/3 minus 1 is negative 1 over 3, plus, so minus, sorry, that's a minus sign right there. Go back and do that. It's a minus, because of this minus sign right here, 3 over 4, x, negative 3 over 4 minus 1 is equal to negative 7 over 4. And just like always, we don't like it when we have negative exponents. So what I'm going to do is I'm going to simplify these. The f prime of x is equal to 1 over 2x to the 1/2. So that's like that, plus 2 over 3 x to the 1/3 minus 3 over 4 x to the 7 over 4. Once again, we're going to simplify these, and so we can get rid of those exponents. That's a prime right there, is equal to 1 over, let me go back to the bottom right here. So what we have is 1 over 2 radical x plus 2 over 3 cube root of x minus 3 over 4. Let me just extend this line over here, and I'm going to get the 4th root of x to the 7th power. And this right here is my derivative. So once in a while, you are going to have to rewrite your functions so that you'll be able to use the rules a little more easily. Okay, so let's take another example. And so you get a mix of different things here. I have cube roots, I have the 4th roots, and I have fractions. So like what we did earlier, we're gonna first write all of these out so that we can get fractions that are easily used. So what I'm going to do is I'm going to rewrite this as y is equal to x to the negative 1. So I'm going to push all my variables up to the top. Actually, let's do this. Let me erase this and we'll start over. So what I'll do is first I'll get rid of the roots. And so I'll rewrite the roots as 1 over x plus 2 over x squared. And right here, I'm going to write my cube root as x to the 1/3 minus 3 over x to the 3 over 4. Okay? So now my root notation is gone. So now I'm going to move all my variables up to the top. So if I want to move them to the top, I just have to make my exponents negative. So I'm going to get x to the negative 1 plus 2x plus, let me see, plus, give me 1 minute, real quickly, Hmm. So I get, let me delete that piece right there. Delete. Okay, so what I'm going to do is, sorry, let's do that again. Let me just delete this piece. Okay, so if I continue, I'm going to get this and get 2x to the negative 2. And I'm going to get, that was up here, sorry, that was a plus. I'm going to get plus x to the negative 1/3 minus 3 times x to the negative 3 over 4. Alright, so if we now write the derivative, I get dy dx, which is the symbol that I'm taking the derivative of y. And if I use all my power rules, I get negative x to the negative 2 minus 4x to the negative 3 minus 1/3 x to the negative 4 over 3 plus 9 over 4x to the negative 7 over 4. Let's make sure that it's a negative. And then if I am to simplify this, I'm going to move all my negative exponents back down into its denominators, and I'm going to get negative 1 over x squared minus, minus 4 over x cubed minus 1 over 3 cube root of x to the 4th plus, the plus right there, 9 over 4x to the 4th root x to the 7th power. There's no 7. And so this right here is your derivative, and it's simplified. So once again, if you have roots, you're going to want to rewrite them into powers. And before you start using any of the rules, you're going to make sure all of your variables and denominators are moved up to the numerators so that you can use the 4 rules easily. That's the end of part 1, and I'll have part 2 soon.